everyone. In the last class we have studied two tests for uniformity. In this video we are going to study about the test for independence. Okay, test for independence we call it as a autocorrelation test. Here we use rho im as a autocorrelation function, and we have to find out the autocorrelation between the numbers, that is the random numbers ri, rim, I plus m, I plus 2m, like that, I plus m plus 1 into m. Where this m is the largest integer, we can just write it as I plus m plus 1 of m, that is less than equal to n. This n is the total number of values in the sequence, that is your total number of random numbers. Okay, the following test will prove, means how you have to prove the independence. This is the hypothesis, you know, h0 and h1. So here, if rho im is equals to 0, then we can say it is the numbers are independent. If rho im is not equal to 0, then we can say the numbers are dependent. It is not independent. Okay, here the values of m will give you the distribution, that is rho im, which can be denoted by rho im cap. Okay, this one we call as a normal function or the normal distribution function for your autocorrelation test. This can be just find out by using this, means the statistics can be formed using z0 as equals to rho cap im divided by sigma of rho cap im. I'll just tell you what it is. This rho cap im is a autocorrelation, and then this is the standard deviation of your autocorrelation. Now we'll see the procedure to solve this problem. The very first step is calculate m using I plus m plus 1 into m less than equal to n. Okay, using this formula you have to find out the capital M. Then we have to calculate the modulus of z0. Already we have seen the formula for z0. So this is rho cap im. I have just told you rho im is a autocorrelation, and this is the standard deviation of your autocorrelation. Then if you need to find out z0, first you have to find out rho cap im and sigma of rho cap im. Here is the formula to find out rho cap im, that is 1 divided by m plus 1, and this, and sigma rho cap im, this is the formula to find out this one. If you find out these two, then you can go for modulus of z0. And then step 3, you know, in each and every problem we'll use the critical value. Here the critical value is not alpha, it is alpha by 2, and you have to take it from normal table. We can just call the table name as A3. It is A3 table. Okay, from A3 table you have to find out the value for this. And the last, it is as usual, you have to just check z0 is greater than alpha, z alpha by 2, or it is less than equal to alpha by 2. If it is greater, reject the hypothesis. If it is less than equal, then accept the hypothesis. Now let me move to the problem. Consider the sequence. Here the sequence will be given. Test whether the 3rd, 8th, 13th and so on numbers in the above sequence are autocorrelated. Use what? Alpha is equals to 0.05. Okay, here in the solution part, what is this formula? In order to find out this m, capital M, we have to use this formula. I plus m plus 1 into m less than equal to n. Here you have to find out the value of I, the value of m and the value of n. Then only you can find out the value of m. Here it is given. Now I is equals to 3. Why I am taking I is equals to 3? See here. Test whether the 3rd, 8th and 13th so on numbers in the above sequence are autocorrelated. They are starting with the 3rd digit. So I is equals to 3. Okay, I'll just write. It is beginning with 3rd number. So I am taking I is equals to 3 and n is equals to 30. There are 30 numbers in this sequence. In a single line, 10 numbers we have 10, 20 and 30. So n is equals to 30. It is numbers in sequence. And then m is equals to 5. Okay, m is equals to 5 means it is the difference between these numbers. Okay, see 8 minus 3 is what? 5. 13 minus 8 is what? 5. This difference you have to take as small m. Okay, this is difference, that is 8 minus 3 is equals to 5, 13 minus 8 is equals to 5, and so on. So I'm just taking m is equals to 5. Now we have the values for I, small m and n. Now you have to find out the value for capital M. See, I'm substituting all these things. So I'll just take this 3 this side, 30 minus 3, then 5, 27 divided by 5, and m less than equal to 5.4 minus 1, that is 4.4. M is the largest value. We know largest integer. So we have to just use the flooring function for this one. Therefore m is equals to 4 we have to take. This is your capital M. M is equals to 4. Now we have find out m value. Now you have to find out sigma cap and what? Rho cap and sigma of rho cap. See, this is rho cap Im is equals to 1 divided by m. See here, you have seen 1 divided by m plus 1 summation k is equals to 0 to m. That is from 0 to m, I plus km, I plus m plus 1 comma m minus 0.25. Here, how you have to take this one means, see here, rho cap Im is equals to 1 divided by m plus 1. M value we have already calculated. It is 4. 4 plus 1 is 5. Here, this part. See, in the question they have mentioned from the third number you have to start. So, see which is the third number. 0.23. Third and then 8th and then 13th, like that you have to go. From here you count 5 numbers. 1, 2, 3, 4, 5. That is 0.28. 0.23 into 0.28. 0.23 into 0.28 plus again this one 0.28 into 5 numbers again. 1, 2, 3, 4, 5. That is 0.33. 0.28 into 0.33. Next again 0.33 into next 5 numbers again. 0.33. 1, 2, 3, 4, 5. That is your 0.27. 0.33 into 0.27 plus 0.27 into next 5 numbers. See, 0.27 into 1, 2, 3, 4, 5. That is 0.5. See here, 0.27 into 0.5 plus 0.05 into next 5 numbers. 1, 2, 3, 4, 5. 0.36 into 0.36. See here, next only 2 numbers are there. We don't have 5 numbers. So you have to just stop here. Okay. Until you get the sufficient numbers, you have to write. Means once the sufficient numbers are not present, then you have to stop counting the numbers. So I have just stopped over here. Minus 0.25 according to the formula. If you just find out this one, you will get it as rho cap Im is equals to minus 0.1945. Okay, this is how we have to calculate rho cap Im. Then sigma rho cap Im. We have a formula 13m plus 7 divided by 12 into m plus 1. M value we have already calculated. 13 into 4 plus 7 divided by 12 into 4 plus 1. You will get it as 0.128. Now, rho cap value you got, then sigma rho cap value also you got. Now you have to find out the Z0. Z0 is equals to minus 0.1945 divided by 0.128. You will get it as minus 1.519. You know, in the formula we have a modulus sign for that one. Z0 modulus. If you keep inside the modulus, then it should be a positive value. Negative will be converted as a positive value. So I'll get 1.519. Okay, Z0 value also we have calculated. Now what you have to do? You have to just see the table and you have to just find out the value. See here, in the previous problems you have D alpha, then Z alpha like that. But here you have Z alpha divided by 2. If you have Z alpha divided by 2, first you have to do it as 1 minus alpha divided by 2. This is the standard format of this problem. Okay, so see here we have to make 1 minus alpha divided by 2. 1 minus alpha divided by 2 means alpha value what they have given in the question. Alpha is 0.05. So 1 minus 0.05 divided by 2. You will get it as 0.975. In the previous table, we were searching with respect to the alpha value, but here you have to search for this value in your normal distribution table. Okay, so I'll just show you the table. See here, this is your normal distribution table. Here you have to search for 0.975. Where is that 0.975? See here, 0.975. It is in which column? 1.9. 1.9, 0.975. If I go little upwards, you can just see 0.975 is with respect to 0.06 and 1.9. So here z alpha by 2, I will write it as 1.9 plus 0.06. 1.9 plus 0.06 means you will get it as 1.96. So z alpha by 2 value is 1.96. You have to search for 0.975 in the table, and the corresponding values you have to take from row and column. 1.9 plus 0.06. The value of z alpha by 2 is 1.96. This is very, very important. Okay. And then as usual, you have to just compare this with z0 value. Z0 value we have got as 1.519. Here z alpha by 2 value we are getting it as 1.96. As usual, 1.519 is less than 1.96. So you have to accept the hypothesis and the numbers are independently distributed. This is your autocorrelation test. And 2 more topics are left out in this one. I'll just explain in the next video and we'll complete with the second module. Thank you.